This is the Amp Hour Podcast, released June 4th, 2017. Episode 346. An interview with Joe FitzPatrick. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, I'm Joe FitzPatrick with securinghardware.com.
Welcome, Joe. We're going to talk a little bit about, we're going to talk about hardware security. We've had a couple people in the past, and Dimitri recommended you join us, and I'm glad you did. Thank you for joining.
Thanks for having me. I'm glad to be here.
So could you tell us a little bit about, how you got into that whole world and what your background is?
So my background was electrical engineering, but very far into the computer engineering and down into the silicon layer. I worked for a tiny CPU manufacturer for about 8 years. I did speed path debug of CPUs, and then I moved into hardware security pen testing of desktop and server CPUs. That was lots of fun. But what I really enjoyed, both through college, before that, and since then, is training. So in the past 4.5 years, I've been running my own business, securinghardware.com, focused on hardware security training, which turns out to be kind of a niche.
Yeah, definitely. So when you say pen testing around processors specifically, is that like you're on die, like actually probing silicon, or how does that work?
Well, it's all a matter of what is in scope in any given situation. So most of what we did was looking at software-based hardware attacks. So what code can I write that is going to use the internal silicon features, the instruction set, the built-in devices, graphics, anything else, to misbehave and allow me to essentially attack other things in the system. Interesting.
Okay. And so you basically had to have you had to know where all the demons were in the silicon, huh?
Yeah. And it's interesting. A lot of people who do security, they think about like layers of abstraction, and software security is all about like finding the flaws in the abstraction layer. But a lot of software people, a lot of security people, they get to the hardware and they kind of think of this as some sort of like bedrock and firmament that doesn't change. In all reality, hardware is, as we know, like layers upon layers of abstraction that have been built up over the past 40 years.
Right. Yeah. That's and so are you usually, where would you usually start with that kind of thing? So would you start like attacking like a driver level kind of software, or what would you, where would that usually start with, and where would it end up?
So when I was doing that, we had full internal perspective on everything. So I would do Verilog code review first before the silicon existed. And then once I found interesting things in that, Verilog makes a lot of assumptions as you synthesize it. So those assumptions turned into my test cases, which sometimes I could confirm pre-silicon. Sometimes I had to turn those into post-silicon test cases to say, if I set this address this way and run this series of instructions, what will happen? That's okay.
And so did you have to know a lot about like how the Verilog compilers were working and everything then, or I guess the interpreters, or however you say it?
Synthesizers. There's a few like very common errors. I mean, in software security, you have like your common class. I think WASP has 10 top security issues. When it comes to Verilog, it really comes down to like misassigning and using the wrong variable name, and poorly documented case statements. Like once you narrow it down to those two, suddenly you find 90% of your issues.
And so why the poor documented case statements?
With Verilog, there's a lot of assumptions that are made. If you make an incomplete case statement, it assumes what you expect to do, and you might think, this branch of this case statement doesn't matter. It should never happen in hardware. I'll put an assertion in there just to check for that. That's great for testing, but assertions aren't synthesized on hardware. Assertions are just there for simulation and testing.
And so does that end up like in a state machine then? Like do those errors propagate down to state machines? Is that kind of what it ends up as, or what?
Essentially, you basically expose things to software that shouldn't be exposed to software.
Interesting. Okay. And so so you're saying that like, so usually a register set will be controlling some lower level hardware, and you're saying that something might pop out, that register might have access to that lower level hardware where it shouldn't. Is that kind of right?
Exactly. Or you have a situation where the documentation says very clearly, set this bit for mode 1, set this bit for mode 2. Do not set these bits at the same time. Well, what happens if we set these bits at the same time?
Guess what I'm going to do, right? Don't tell me what to do, document.
Exactly.
Oh, that's great. Wow.
Or
Wow,
another great one, which hopefully I'll anonymize enough. We had one part of the documentation which said, okay, this value is ANDed with that value. The other documentation for the second value said this value is ORed with that value, right? And these two registers were used by two different groups for two different purposes, and both thought their logical combination was correct. Of course, in silicon, only one of those two combinations is going to exist. The question is, which one was it, and who was right?
Wow. Okay. Man, that's crazy. So, like, what? So, I guess you'd have to take us kind of where this all exists in the development time frame too, because I don't even know. Like, how far is it usually from looking at Verilog on a page to like a piece of silicon on your desk? I mean, I guess that's kind of matters too.
So, the whole timeline from like conception and architecture to silicon that's sellable is several years. So typically it'd be like, you spend the last year of development looking at the Verilog, and then you get first silicon and you think, oh, this is great. I have first silicon. I can start doing my hardware tests. Except when you're doing security, your job is to make it not work. And it already doesn't work. So sometimes it takes 3 or even 6 months and multiple steppings before you have a working platform running a working operating system before you can turn around and break it.
And so it's like a lot of setting up a thesis of like, oh, well, I think this will happen. And then you have to like really well document it so that future you looks back and is like, oh, what was I thinking here?
Exactly. Well, and then the dilemma of if you have multiple products you're working on, you might do the pre-silicon for product A and then have to move on to post-silicon for product B before the silicon is ready for product A. So a lot of context switch.
Yeah. I mean, I think that's the thing that, so like, having you on here and then, Mike Osman and Dimitri and everybody who's come on, Joe Grand, everybody who's been doing security stuff. I'm going to forget someone now. Colin, right?
Yep.
Did I forget anyone? Anyways, I think the thing that, so like my perception of it has always been like, oh, well, it's like this thing you do after the fact. You're not really, I never thought about people that were at the companies doing this stuff. But the thing that way it's changing my mind is like this, it's this, not regimented, but this well controlled, it's like it's a avocation, right? I don't know, like that's the wrong word, but it's like it's a well documented thing that happens.
Well, it sounds like that, but I would kind of disagree. There's really a very small handful of people who are doing this type of hardware security and pen testing. There's only a handful of companies that are making silicon that are big enough to actually care about and put effort into security.
Well, I meant, sorry, what I should have said is the way I've heard it described to me is how it should be done, and hopefully more start doing it. Maybe that's a better way to say it?
Yeah, perhaps, yeah.
Yeah, right. That it's just that the industry can be done like as like a studied thing, and I just never thought about it like that. So it's cool. So why did these companies that you were working for, were they just big enough that they had hired you, or did you kind of did you study under other people that were doing this kind of thing as well? How did you get into that piece?
I didn't actually come into where I was working from the security side. I came from the product side and built up a really deep familiarity with all the debug features in the products. And that turned into very useful when it came time to look for people who needed to do the security testing as well. So the group I worked with was a lot of people who had strong software security backgrounds and a lot of people who had strong product backgrounds. And together, you had the audience of people who had hardware security capability.
Interesting. Okay, so what? So you said you got more into the training side of things. How have you seen things change? I mean, you've been doing training, you said, for 5+ years.
Yeah. So I started out training, and what we were doing is training all the people who were doing hardware validation. So like, does this interface work? Does memory accesses work? Do drive accesses work? Convincing them like, okay, if you find something interesting, could you please recognize whether it has security implications and just flag that for us? Because when you're dealing with a giant, a giant silicon product, you have hundreds upon hundreds upon hundreds, maybe thousands or more bugs. Some of them have security implication, some of them don't. So I trained hundreds of people who were doing functional validation on how to recognize a security bug, and I really enjoyed that and wanted to do more. And the timing all worked out well. That's what I decided to do when I left.
I see. Okay, so you're doing internal training, you're saying?
Yeah, so I was doing internal training, and that flipped into external training. But then I look at external, and I can't, really... There's not a huge audience for silicon security.
Yeah.
There is a huge audience for embedded systems and now IoT and everything else. So,
You don't say. Wait, so there have been problems with security and IoT? That's
people
weird.
keep telling me about them. I haven't found any yet.
Wow. Okay.
I see opportunities, not problems.
Nice. So how do things change then? So now you're on the outside, right? So you don't have access to register sets or hidden stuff. So how does that end up changing things for you?
Well, so what's really interesting is, one of the things that frustrated me when I was working on CPUs is I'm dealing with like deep down in the middle of the silicon, barely documented or accessible to the outside world things. And there are security issues there, and they get found and fixed. But there's this whole world of embedded systems and low-hanging fruit and everything else that is, I should say, perhaps saying it's easier is not the best way to put it, but it's easier, right? You can go and
I like low-hanging fruit. That's good.
Yeah.
I mean, like, yeah.
You go and you open up any, off-the-shelf consumer electronics device, and there's a dozen things that'll pop out and say, oh, this is interesting, this is interesting, this is interesting. Can I get firmware? Can I get, JTAG or, debugger control?
Yep.
Those are things that are very accessible to a wide range of people. They're actually really inexpensive to do these days. And, in the past 5 years of doing trainings and working with a lot of consumer off-the-shelf products, I've seen an actual improvement in the security of these things, which is great.
Oh, that is great. Yeah. So, and I mean, the thing that I always hear about with the security stuff too, because I'm obviously on the outside of all this whole world, but the thing that I always hear is that like it's always the weakest link is still always people. So like you're saying, like someone just hung the firmware out on the internet, and it's like, okay, I'm going to go deconstruct this, or someone didn't obscure the pads, or even if they didn't do it well, that kind of stuff, right? I mean, like all these things are very human-based errors where the silicon is a much deeper level.
Yeah, so when you look at like the big picture, I decide that there's some IoT device that I want to hack, right? I can look at it from the software perspective, right? I can, go put it on my network and start doing network fuzzing, like throwing random input at it. I can do it from a purely network perspective and try and do something remote. Try and find these devices, shared publicly on the internet somewhere. I can do a physical approach where I open the device up and I look for debug headers and stuff, and I try and, extract firmware from flash chips. Or I can do a deeper, like, silicon level attack where, I might use like a chip whisper that Colin makes, or some other attack to do a side channel attack or invasive decapping. Every one of those has a very different cost and time required and skill set required. And whichever one is easier is really where people are going to go.
Yeah.
So, I mean, I talk about in class, like, oh, here's 8 ways to go dump firmware. But then what's the easiest way to get the firmware? You just go to the vendor's website and download
it. Yep. Yeah, that's true. Yeah. And that actually, okay, I remembered another name. Sammy was on the show too. Yeah. He talks about that stuff all the time where he's just like, yeah, I just did it with an Arduino. It's like, who cares? I'm just doing it. I'm getting it done, whatever. I'm just throwing bits of this thing or doing whatever it takes. And that those kind of methods too, where it is, it's just you have this toolbox of ways to get into something, and whatever wrench fits, right, or whatever socket set fits.
Exactly. And what's really interesting to me is when you're building a product, you need to make something that's got a certain level of reliability and repeatability, and you have to be able to manufacture it. So you have a lot of parameters. So what you're going to do in a shipping product is a much smaller subset of what you can do when you're just trying to get it to work once. So, you can bit bang a protocol with an Arduino and have it work, 1 in 10 times, and that's a valid attack. But if you're shipping a product and it only works 1 in 10 times, then that doesn't really work. That's not
well, that product's probably not shipping. Hopefully not shipping. Yeah, that's very true. That's interesting. So how does this end up? What kind of form does this take then? I mean, when now you're out in the world, you're teaching classes. What are people like using this for or looking to learn? Is it like people that are building products and looking to secure them, or is it something else?
That was my interest at first. My focus is the product side. My background's the product side. So I was looking to talk to the people who are designing products and get some security mindset in their work. What it turns out is there's a lot of people who are, pen testers who work for security consultancies. They're the ones who are doing the web-based pen tests, the software pen tests, and now are doing IoT pen tests, and they need the skill set to touch the hardware. What's interesting is I've had a lot of conversations recently and trying to tune what I'm doing in class, and people get contracted to do a pen test on an IoT device, and they say we only want a software pen test. Like, well, why do you only want a software pen test? Well, because the hardware is hard. It's inside a case. We use screws that they can't get the bit for. Yeah.
Yeah.
And so. Right. Part of that is
that's what you should do with that. You should just have like a standard response where you just fire up a Dremel. Like, you know what that sound is? Yeah.
Well, and that's the thing is giving people the stock responses to these excuses for why hardware is out of scope. And one question I often pose is, okay, I understand hardware is out of scope. You don't want to talk about physical attacks because you think that your hardware is expensive, hard to get, or going to be physically secured. What about the fact that I can buy one of these off the shelf, open it up, extract the firmware, and then I can do full, reverse engineering of the firmware and figure out my software attack, figure out my network attack. That's where I think the compelling reason to put hardware in scope is.
That's good. Yeah, no, that's really good. I mean, because you're right. I mean, like people think that it's like this captive thing. Like firmware is not something that's not accessible, right? It's like, yeah, it's only as safe as someone is not tenacious, right?
Yeah. Well,
if they're tenacious, they're going to get it.
I talk at a lot of security conferences, and sometimes I get there and I speak and give a presentation, and then I get questions. And the questions often point out to me sometimes I'm worried I'm just basically getting up there and spouting out EE 101, and I actually am. I'm up there spouting out EE 101, like connect a wire, and we get signal. That's it. But then the questions show me wow, when you have a software background and you have a security background, the hardware is like a black box to you. And getting up there and getting people to understand, it's not a black box. There are ways in, there are nuances, there's lower layers, there's abstractions. That's really powerful. It's kind of like, within the security community, everybody talks about, we're just, the echo chamber. We keep going to conferences and we have security people talking to security people, telling everybody how bad security is. We need security people going to, development conferences and hardware conferences talking about security. And it's kind of the reverse of that. I'm the hardware guy that goes to the security conference and says, hey, look, all these assumptions you made, here's how they're perhaps invalid.
Wait, you were about to say you're dumb, weren't you?
No, I was not.
All you guys, you're dumb.
So that's the other thing I say. I'm doing training for now because I want to teach all these smart security people how to understand hardware. Because in 5 years, when all the smart people start doing it, I'm outclassed. Some of this stuff that these guys do is amazing.
Yeah, no, I know that, and that's just like the stuff that they keep trying, and and the mindset too. I mean, it really is that tenacity that consistently impresses me. Of well, this didn't work, so I tried this. I didn't try this, so I tried this. That's great. I mean, that is really admirable.
Well, and another example is one of the projects I worked on. One of the first ones I did was Slot Screamer as part of the NSA playset. It's a PCI Express device based off of an off-the-shelf chip that you can program to do DMA accesses. So you can stick this card in a system, and barring any other protections, you can go and read the contents of memory and modify the contents of memory. And you can use this to bypass lock screens, modify kernels in memory, all that stuff.
Wow. Okay.
So what I did is I just did the basics. I plugged it in, I had the proof of concept, you could read and write memory, and I had one example. And I thought okay, that's cool. And it's really interesting because this past year, another guy, Ulfrisk, he built a whole software suite behind this. So he's got this thing where you plug it in a system, and you run his software, and it goes and like opens up shells. It gives you file access. It does all this stuff, and all that is a layer of software built upon a piece of hardware. And
Right. Right.
it's really neat to see this.
Yeah. Right. And it does it just like automatically. It's like, I mean, that's like some movie stuff right there, right? Where it's like they plug it. I always remember the one where it's like you plug it in and then it's like running through the door codes. It's like, okay, come on, like like that one always bugs me. But like that kind of thing where it's just running all these, it's just trying all these things, right?
Yeah, so the demo I had is, you plug it in, and actually at that point in time, Macs didn't have a couple of protections they have now. So you plug in a Thunderbolt cable, right? And you just have it sit there, and it scrolls through, and it reads through your memory until it finds the code that checks your password, right?
Wow.
And it patches it, and then you walk up and you bang, 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 bang a bunch of stuff and hit enter. Doesn't matter what happens because it always passes, and it always removes the lock screen, and you're logged into the computer.
Oh my God. That's
Luckily, they've put some countermeasures in place about that on Macs at least.
Well, they have done that since, or
they've done that since Mac 8, okay. 10.8.2 and later.
Yeah, update your software, folks.
Yeah.
Wow. So, I guess that's a good question too, because I think when Mike was on last time, he was talking about his behavior in hotel rooms. But he unplugs everything from the walls and turns the TVs away. It's like, and well, you posted that great picture of the mirror.
Oh yeah.
On Twitter yesterday. So, how do you view security now? I mean, what is your feeling about it all?
Well, it's funny. I have a kind of a fatalist approach to it, right? We've got such huge stacks of software that are sitting on such huge stacks of hardware, and a lot of them are very poorly tested and stressed. So what it comes down to is, you've got all these, ODay vulnerabilities, this leaks and drops of exploits. You've also got all the things that have been sitting there unpatched. You've got all these devices that are on, ancient kernels that have vulnerabilities. So really, and then you've got social engineering on top of that, like the guy who showed up and pretends to be, the guy from Amazon Prime delivering something some guy sent you, right? And I'm just going to plug this into my computer because he sent me a microphone to talk on the show. Who knows?
This may have happened an hour ago.
Who knows what this device is, or what extra firmware is on there? So what it comes down to is there's so many issues, right? You have basic security sanitation, the whole password thing, and don't trust random devices, and that protects you from the bulk of the undirected attacks. But if someone wants to get on your computer and someone wants to get something you're doing, there's just so many paths to do that if you're targeted, it's only a matter of time before the persistence pays off. So
got it.
So
you don't avoid network services or anything like that. Obviously, we're talking on one right now. So
no,
you're hooked into the internet.
I'm on the internet. Yeah. I did turn off my VPN so that we would have lower latency on this call, but
Oh, thank you. That's very nice of you.
No problem.
Yeah. Yeah, and I mean VPN. I mean, I think that obviously the internet is back, kind of with the net neutrality stuff. That's kind of coming back up again, and it's ridiculous. But that's a lot of people are talking about VPNs again and just general security stuff. So you're just saying you're always through a VPN. You're always doing that kind of stuff.
Yeah. And I kind of feel like I need to have a slightly higher bar than the average person. But I avoid plugging in random USB devices that I get handed at conferences.
Smart. Yep. You haven't concreted your USB ports or anything like that?
No, I haven't. And there's pros and cons to that. It's paranoia versus usability.
Yeah, I wonder if do you think USB-C with all the negotiation that has to happen between devices? Do you think that'll actually improve things? Just because it's not direct?
Not at all.
No, okay.
Not at all. It is. So basically, what we've got with USB-C, and I've done quite a bit of poking at it. Every device you plug into USB-C now needs to be smart. Any cable that you plug in that does anything beyond basic USB has essentially a microcontroller in it, right? So I've actually got a USB-C to VGA adapter that I've been messing with.
Okay.
And I'm like, okay, so how does this work? I open it up, and I know USB-C can output DisplayPort, and on this little device is a DisplayPort to VGA buffer chip. Okay, that makes sense. There's also a USB power delivery chip and a USB microcontroller. And I'm like, oh, okay. So let's plug it in and
So
see what I can do. Oh, it turns out direct firmware update is available on this USB microcontroller. I can dump the firmware off of this device. I can flash new firmware to it.
oh god.
So the way it works is it connects via USB 2 and says, oh, I'm a display adapter, right? There's a little negotiation that happens and spits out display. That USB microcontroller is sitting on USB. And now I can read and write the firmware for it. So my theoretical attack that I have yet to implement, because I have not had enough time to sit down and do it, is, okay, can I make this USB-C to VGA adapter also appear as a keyboard that hits the forward and backward keys while you're presenting? So, it just keeps changing your slide for you.
You just go around, you're like offering it to presenters, like, oh, you got USB, you got one of those new Macs, you need one of these converters here? Yeah.
Uh-huh.
Oh my
so here's
god.
the dilemma, right? From usability, you've got this universal port, a universal cable, and a universal adapter. So you don't have to worry about what you're hooking up. But at the same time, you have no way of knowing what you're hooking up, right?
Yeah.
I look at a device, it's a box, it's got a USB-C cable. Is it a display adapter? Is there extra stuff inside? I have no way of knowing without truly taking it apart.
So there would be so people listening might have a notion to build a product that basically intercepts the signal of what it's saying it is before you let it through or something, like having it would be a man in the middle, but it's more like a monitor in the middle of what is this thing saying it is, and then is this okay or not okay? Is that something
like
that
a
might
USB
work?
firewall essentially?
Yeah, that's a great name for it. There you go.
Yeah,
product idea.
I know there's USB Proxy, the project that Dominic Spill did on the Beagle and Black, which I don't know what state that project's in, and it's only USB 2.0. But that kind of idea, we have USB, we plug it through this thing. Let's look at the traffic, let's filter the traffic, or let's inject the traffic.
Yeah, right, and that was one used for testing, and they were trying to do. Dominic works with Mike too, right?
Yeah.
Yeah, and they're trying to do a USB protocol analyzer at some point, right?
Oh yeah, Daisho. That's kind of an interesting project. I was just talking the other night with Jared Boone about it, and wanting it to happen, but it's just a very complicated and advanced project that requires a lot more time than any of us have.
Yeah. Well, you guys get conferences and trainings to do, so people keep paying the bills that way, so that helps, right?
Yeah.
nothing to sneeze at. Man, that is crazy about the USB-C though. I didn't even think about that, because you could also couldn't you plug in and say I'm a mass storage device as well, and I have the script to auto run or whatever. Not that auto runs always work, but
so you can basically have a situation where you walk up and you have USB-C and you plug in this cable that's coming from the monitor, right?
Mm-hmm.
And your display shows up on the screen. You're like, oh, okay. Oh, and you're also charging over that as well. So okay, I have my laptop, I plugged one cable in, I see display, and I'm charging. Oh, it also has a network adapter in there, so I'm directly connected to the network. Okay, that's cool. Oh, it's also a keyboard. Interesting. It's also a mass storage device. So you have one cable, you don't know what's on the other side until you plug it in, and suddenly you have connected all these standard I/O ports on a PC to another piece of hardware.
Now
right?
I'm already getting a little anxious, I gotta say. Maybe I shouldn't have gotten this one after all. I'm really excited about USB-C. Don't get me wrong. I think it's awesome in general, but now I'm oh, maybe not.
No, and I think it's great too. And I have an XPS 13, which I got as soon as it was announced, which is one of the first ones that had Thunderbolt 3. So it's on all the USB-C stuff plus PCI Express over it as well.
Oh Jesus! So is there any in between layer there? What do you usually use that for?
Testing and playing with things.
So why is PCI Express on that bus though? What are they expected?
So
for big DMA
basically,
dumps?
USB and Thunderbolt kind of have converged into USB-C or Thunderbolt 3. So it's the same connector, similar protocol, hardware layers. And it just means that, there's one fewer adapter in the world, one fewer cable in the world. Well, that's not true, because there's specific USB-C Thunderbolt cables that don't necessarily work the same as others. But, it's a good idea, right? You're converging. You're going to have fewer cables, except it's not there yet, right? You actually, I think Apple has a great list of all the different versions of the USB-C cables they have. Some of them do USB, some of them do USB-C with DisplayPort, some of them do Thunderbolt 3. It's not easy.
Wait, don't some of the cables have to be like not certified, but do they have like little ID chips in some of the cables too?
Yep. So there's chip in the cable that identifies the cable. It identifies the way that the cable can maintain the power that you're asking to draw through it.
Yeah, right. Yeah.
So
yeah, because we had Jason Sorrendel on, and he was talking about some of that stuff. Yeah.
I got his USB Type C power delivery breakout boards to do some cool stuff. And I liked his toaster oven that makes cookies off of USB-C.
Yeah, that thing is fun. Oh man, that is okay. Well, welcome to the future, huh?
Yeah.
Oh. Well, so what else is scaring you these days? I guess these always turn into fear-mongering shows a little bit, but it's also like this kind of healthy, because it's like you guys are doing this because it's kind of clear and present danger type stuff. It's like, well, no, we should be thinking about this because it's out there, right?
What scares me? I don't know.
I guess maybe I should ask about, you mentioned NSA Playset. I mean, you said, is that still going on? What's the deal with that?
Yeah, so the NSA Playset popped up after the whole Ant catalog article that got published like 4 years ago now. And so several of us all, basically branded our hacks that year as NSA Playset, right? These are reimaginations or similar devices to what the catalog had, but we're going to do them with open source hardware and do them cheap. Which is cool. On the one hand, the Ant catalog was several years old at the time.
Right. Yeah, so they're on the next model.
So
right?
we're mimicking the last gen. But yeah, it was neat because I guess the way I present it is before 2012, right? Our mindset of like what is a hardware implant? An implant is kind of the intelligence term for like malicious software you put on a system. So a hardware implant is like a malicious piece of hardware you plug in somewhere. Our mindset was like, oh, what is a hardware implant? Okay, so basically mod chips for games and drive chips for game consoles was the extent of our public knowledge of what these things were. And then suddenly we see all these leaked documents and pictures of like, oh, we have a USB cable that also has a hub and a radio in it. Oh, we have a device we plug into the JTAG port on a motherboard and it persists malware. So it really changed my perspective on a lot of these things. And being a hardware person, what it also showed me is, so first off, these things are real. There are people doing this stuff. Government agencies doing this, nation states doing this. But also, what was neat for me is because all of these devices basically were hardware devices you plug in to give software privilege and then go away, right? My mindset is
the hardware goes away, or the software goes away.
It just doesn't do anything else, right? My mindset was always like, if I have hardware access, I can do everything, right? I'm a hardware guy. That's how I think. But
right, you're thinking about a wire that's persisting and you keep pushing bits through it. You're saying.
But the way these things were all designed is like, here's a hardware device. It's going to sit on the bus and it's going to give root access to someone, and then it's going to be doing nothing else because you've got root access. Why would you need to do anything else in hardware when you've got a root shell remotely? Right,
exactly. And it's better because then it's harder to find, right? Because that one time you have to actually be there right when it happens, or else you don't detect it. It just looks like a dumb USB stick or whatever, right?
Well, and think about the number of people who look inside computers these days, right? How many people would look inside their computer and notice if there's an extra board soldered on somewhere and think something of it?
That's true. Yeah. Oh my God.
Maybe people who listen to your podcast would not, be concerned about that. But like the vast majority of people, like the thought of even opening a case is unfathomable. So opening it,
mostly for dust for me. It's just it would hit my nostrils pretty hard. But but yeah, no, you're right. I mean, like you're saying like the now the Amazon Prime guy it's not the Amazon Prime guy showing up. It's one of those, the Best Buy repair people, right?
Yeah.
And they're coming to fix your computer, but at the same time, there's a new board in there, and whatever. Oh, we made it faster.
Yeah, it's an upgrade.
Yeah, right.
Aftermarket upgrade.
That's right. Wow. So that changed your viewing of it. So does that mean that it changed the kind of stuff you were developing or testing for, or how do you test for that then? Is it just like, well, open up your computers?
Good question. How do you test for it? I haven't solved that problem.
Okay.
What it did for me though is it made me realize that I didn't have to put all the effort into making this like hardware device that goes and pops root shells and deletes this and reprograms that. I just needed to have the hardware device that converted hardware to root shell. And then software people would like understand the implications and the value of that. So again, my focus is training. I do like all my side projects and research, present those at conferences, and hopefully get people to think about hardware security a little bit more. But yeah, so like I don't need to, do anything other than pop a root shell, and then it's a software problem. It's someone else's problem, right?
Right. And when you say pop a root shell, you also mean like so it's connected to something else so that they could get to it, right?
Yeah. So an example is, I mentioned the PCI Express one. The other one is like JTAG, right? We all know what JTAG is. You hook it up, you get debug control over a CPU. It's more complicated for a software person to understand JTAG than it is to like understand like a serial console. But if I can use JTAG and I have a little device, like basically an Arduino that runs through a JTAG, through an SVF, a serial vector format file, which is a series of JTAG commands, right? I plug that into a system and either hit play or have it timed to like play back a series of JTAG commands after a certain amount of time. And that series of JTAG commands could modify memory to change a root password. It could, I have one example where I have a PLC, right? A programmable logic controller that, is used to switch on and off like dams or, other industrial machine equipment.
Right. Yep.
And it's got these little plugs on the front where you can put like upgrade modules in. So you can give like Ethernet connectivity or USB connectivity to this thing. But if you pop that out and you look inside, from the opening, you can see a 10-pin ARM JTAG header. So what I did is I made a little device, I plugged a little Arduino in it, and I had a script. So when I plug that in, it gets power from the connector, it turns on, it waits 5 seconds, it halts the CPU, and writes to a GPIO to turn off your output. Right? And so like that's the extent of a proof of concept I need at this point to show like this is an issue.
Right. This warrants more investigation at the very least. Right?
Yeah.
Yeah, no, that's true. And I think that so I used to work in industrial stuff, and I talked to a couple of people where they were like, they talk about all, because there's all these articles about hacking, blah blah blah, like network connected power plants that didn't need to be, which of course, but like they always talked about it, like, look, yes, those things are a problem, but like if you really want to get at that thing, there's no security, right? There was no like physical security. There was no gate. You know what I mean? Like it was like, yeah. So it's more about just having knowledge of the thing as well. So how do you deal with that? So like, okay, so you know that there's a thing where you could go plug into. There may be a JTAG port there, but then how do you figure out that there might be devices to play with? Do you need like full access to the system to go and then say, well, when I do this, this turns on, or when I do that, this turns off? Is that kind of how you have to probe around, or what?
Oh, so you're saying like how would I adapt that to a real system? Like an actual... Yeah,
well, like, so once you have access to the JTAG port, I suppose. I mean, I know that you have the chain and it'll identify devices, but then even still, what is your method for then going and saying, okay, well, I know this is, a micro that's controlling a motor. You have to go like dump the firmware and like analyze it then, or what's the next step then?
From the PLC perspective, I had a test system that I think I got off a DigiKey, right? I was able to open it up. I know exactly what CPU is inside. I can assume anything the same model is going to have the same CPU and the same base firmware. I didn't actually poke at the firmware at all. I mean, I just did the bare minimum of like, I have JTAG control. I can control GPIOs, right? I can reverse engineer the board and see where the GPIOs are connected to know what outputs of the PLC they're connected to. So what I would have to do is, let's say I go on a tour of like a dam or a power plant. I just look around and see what things are connected to. I'm not saying that I could figure it all out, but theoretically,
right. But then you might also be able to buy like a board from a scrap house, or something like that, and actually have access to like a labeled pin header or something, right?
And it's interesting you mentioned that, because on a tangent, like there's been a bit of poking around at medical devices lately, right?
Oh yeah,
and so
those things never change because of the the regulations.
So someone goes and they get a medical infusion pump and they take it apart and they find lots of vulnerabilities that are remotely exploitable. Okay, that's great. Now they go have the discussion with the vendor, right? And in my mind, the vendor should be like, "Hey, thanks for doing this. How do we fix this? How do we make it harder?" Instead, the vendor is like, "Well, where'd you get that device?"
Yeah,
well, here's the problem. The problem is you got that device. If you didn't have that device, you wouldn't know this stuff.
You mean this device that you sell to people for a lot of money?
You sell it to hospitals, and hospitals are supposed to physically protect it or whatever. But you can still buy these things on eBay. So it's very interesting that their concern, their mindset of hardware security is physical security still, right?
Right.
And
or
that doesn't.
economic security in a way, right? Of like, oh, well, this is not accessible to the public, so it's not a problem. But it's like, yeah, the places that are buying these high-end pieces of equipment are often high-value targets anyways, right?
Yeah, yeah. And I mean, what we're talking about, researchers who publish everything they do, or
Yeah.
most of what they do, approach it. Like I'm not going to go into a hospital and steal an infusion pump and hack it and then talk about it. But if someone wanted to, like, it's pretty easy to walk into a hospital and walk out with something.
Right, exactly. Well, and I guess that's what it all comes down to, right? It's like, okay, will this happen? Probably not. But could this happen? Yeah. And
Well,
and then it's about like whose responsibility is it that it doesn't happen, right?
Well,
Yes.
will it happen perhaps at some point? Why doesn't it happen? Because no one's trying and no one is motivated and no one wants.
Because hopefully
to
people
cause-
aren't a-holes, right?
Yeah, exactly. And I think that's
However, history has proven there's a lot of a-holes out there.
yeah. So as a security measure, we should just make the whole world a-hole free, right?
Well, unfortunately, that is sometimes the
Yeah. Well, tangent, different
Yes.
subject matter.
different podcast probably. So I always do wonder how that conversation goes, right? So someone goes to a hardware manufacturer like that and says, or is publishing about this stuff. I agree with it. I think that it's important, but if I'm being honest, Joe, it always kind of sounds like blackmail to me a little bit. I know it's not, but like, it's like, oh well, this is not secure. You should fix this. There's always like this thing at the, like, it's almost like this hanging sentence of like, and I can fix it for you. You know what I mean? Like, it's not. Is that part of the culture, or how does that work?
Well, I mean, there's part of that. Like there's a situations where someone targets a software, a product, whatever, and finds something, and then goes and reports it to them and says, "I'm going to disclose in 90 days or next week." And the company that receives that, perhaps they've never thought about security. Perhaps it's a mom and pop business or one person show, right? And they're like, "Yeah, I don't make any money on this. Like I'm like doing a Kickstarter or something. And you're telling me that I need to spend X number of dollars for you or a third party to do a security analysis." Like, yeah, that does look a lot like blackmail. On the flip side of that, actually, I've had this conversation the past 2 days regarding the case in Oregon where there's someone who is being fined for calling himself an engineer, right?
Oh yeah, we talked about that a little bit. Yep. I think we were supposed to, maybe, but yeah.
When you're a professional engineer, right, you've got obligations. You need to think about health and safety and all that stuff. And if you're a professional engineer designing a bridge and you skip those things, you're liable.
Or if you sign off without being certified, right? Whatever.
But if you're an IoT, home automation device developer, and your thing uses unencrypted Wi-Fi to control the lock on your door, I kind of think there's a similar realm of responsibility there. I'm not totally answering that. Like, yeah, it does look a lot like blackmail, but at the same time, like, the we can also go down the tangent of like, our vulnerability is free speech, right?
Right.
I find this vulnerability. I can choose to sit on it. I can choose to report it to the vendor and give it to them for free. I can choose to report it to the vendor and threaten to publish it. I can sell it to on the gray or black or whatever market you might want to call it. There's a lot of choices, and there are better choices now than there were just a few years ago. We've got a couple companies that do bug bounties, like administer bug bounties, and will actually help you, communicate with a vendor to fix things. But yeah, it's all very different.
No, I think that's a great example though about the lock. I think, right? Because like, okay, so then it raises $1 million. It's out there. So do people deserve to know that it's a vulnerability, right? Maybe there's no economic bent. It's just like a true concern because you were interested in the product and you were looking into it. It's like, I don't know. I'd prefer to know that, And
well, here's another aspect of it. Basically, if anybody finds a vulnerability, right, an issue in software or hardware, you can have this assumption that someone else should be able to find it too, right? So if I find out that this IoT door lock is trivially exploitable, right, I can only assume that there's someone else doing the same thing, and that someone else may or may not be willing to tell the vendor, may or not be willing to, publish it, may or may not be willing
Right.
to, use it illegally.
They might just be willing to walk into someone's house and make themselves a
Exactly.
sandwich, right?
Uh-huh.
And yeah, that's,
Sandwich,
yeah.
that sounds good.
Security sandwich. Oh. Yeah, that's man. That is it's like I'm sure that there's lots of conference talks about ethics in this kind of realm, right?
Unfortunately, not very many.
Really?
Yeah.
Oh, that's interesting.
There's a lot of bar side kind of conversations about it.
Okay.
But yeah, there are some, but not the majority of conference discussions. But yeah, there are debates on the ethics of it. There are the bug bounty companies, BugCrowd, HackerOne, and others. They really have ironed out the ethics of that field pretty well. So.
Well, that's great. I mean,
Yeah.
it seems like there's some people thinking about it. So that's a great start, right? So
Yeah, and there's also there's an ISO standard on like vulnerability disclosure, which is pretty cool.
really, do you know the number?
I do not know the number, but Katie Mazuris knows.
Okay, I'll look that up on disclosure. That's a cool idea, though. I mean, I think that especially like, I mean, obviously there's so much stuff about autos these days too. I saw something about like, what was it? CAN bus hacking recently, and they were like messing around with the radio via laptop, and I mean that's limited, hopefully, but yeah, there's some real applications there. Like it's scary stuff sometimes. It could get out there pretty fast.
Well, and yeah, there's been people hacking on automobiles for a decade now. But what was really interesting about the whole Jeep case is there was a string of issues all tied together that basically allowed you to do a lot of bad things to a vehicle. And when you just report it, then the vendor's like, oh, whatever, we'll do an update, we'll do a recall and flash the firmware when the next time they bring it in for service. But when you go and like have a video of someone like getting pulled over on the side of the road because their engine cut, suddenly everybody's getting USB drives to do it immediately. So,
right.
Again, is that blackmail? You could argue. Yeah, it is. Is that in the best interest of the safety of people? Probably.
I'll tell you what, I would probably, if it wasn't fixed, I would probably cancel the next Uber that showed up as a Jeep.
Yeah.
Like that's kind of what it comes. You're right, though. At a certain point, like the only thing you have left is like kind of public opinion, and yeah, It's interesting. Well, speaking of conferences, you seem like it seems like we're kind of ramping up conference season, and you've been doing a lot of training. So what's your next, what are you kind of moving towards on trainings and everything?
Well, so next week or the week after next, I'm headed to Recon, and I'm going to help Dimitri with his class on hardware reverse engineering and tooling using FPGAs. And then Black Hat, I've got a couple classes focused on embedded systems and kind of integrating that into a hardware pen test. But the big thing that's coming up is myself, Dimitri, Colin O'Flynn, and Joe Grand are all working together to have like a big hardware hacking training event in San Francisco in November.
What's it called?
Hardware security training.
Editor's note, that was hardware security training. Just had to cut in here.
Pretty straightforward URL. So I'll be teaching my classes on embedded systems. Dimitri will be doing his on using PGAs for tooling. Joe Grand has his on basics of logic analyzers, soldering, and identifying systems. And Colin has his class on side channel attacks. So hopefully there'll be something for everyone there. Well, everyone who's interested in hardware security, at least.
Is that like they're all kind of concurrent? They're all you can only take one, or is it like you kind of take them all?
Dimitri's is a 4-day. The rest are all 2-day classes, so you could pair up a couple of them. The other thing we're looking at doing is we're going to try and get some speakers to come in during lunchtime. So not only would you get some training, you'll get a little bit of new stuff coming from people who do hardware stuff, hardware security.
Oh, that's great. That's and that's going to be in San Francisco. What dates in November?
San Francisco, November 6th through 9th.
Great.
It's a Monday through Thursday.
That's great.
And it's like the hardware security conference without the conference.
All the conference activities will be held at the bar after hours, right? That's cool. That's really good. So people who are listening, who may have heard other shows but are looking to get more into this, what is your usual go-to for like, how do you usually recommend people start getting into this stuff? Well, maybe with training, but even otherwise or at home.
Well, so I need to come up with a list because I get the question a lot, and basically every month or so, someone has taken an off-the-shelf embedded device, taken it apart, and done the basic hardware hack on it. And I love reading those because most of the time it's someone who's new to hardware hacking. It's someone who may have pieced together things they found in blogs or other places and applied them. But it's really great to see different people's perspectives and approaches on how they tackle the same problem, and what they do with it. So, I should make a list of these blog posts that I've seen. One standby is Craig Hefner's Dev TTYS 0. He's got a lot of information on focusing on these embedded devices and taking them apart.
And so, what's the usual goal of that kind of thing? Of just like owning the network traffic from it, or what's the ultimate goal for that thing?
It depends on who does it, but it seems like it's consistently like, I want to get a device, I want to open it up, I want to understand what it's doing, I want to get firmware off, and then use the firmware to figure out how I can make it a software problem.
Okay, that's a good way to say it, I guess. Yeah, it's like so having some kind of control so you can make it do a thing without that it wasn't meant to do, right? I guess.
Yeah.
Right.
Yeah. And the kind of things people find like hardwired backdoors. So like, yeah, we took a hardware approach, but we got the firmware, we reverse engineered the firmware, we find this string, and when I go to that page on the device, like on the network, it automatically authenticates and logs me in and gives me control over the device. Another thing is, devices store keys that let them communicate with a backend, and a lot of times they give too many keys, private keys instead of public keys. All sorts of devices, things like that. Figuring out what root passwords are, hard-coded passwords, all those things pop up really quickly once you've got physical access and you can dump the firmware.
Right. Yeah. I guess isn't there like a list of default passwords for like webcams and all that stuff? That's like there's like just standard passwords for a lot of things that are out there.
Yeah, I know I've heard of that, but I it's not coming to mind immediately. Most of the time, I just Google model number and find the manual, and it tells me the default password. So
wow, again, the easy solution is the right solution, huh?
Yeah, so like I'm at a hotel and they have like metered internet because apparently some places still do this, and I go to their like main page and it's like, oh, it's a whatever brand. Go online, find that brand, find the default password, and sure enough, most of the time it works.
Really?
That's the usual approach. Yeah.
Okay.
And then I go to the front desk and I'm like, oh yeah, thanks for the internet. Oh, by the way, you're still using the default password. And their response is usually like, oh yeah, but no one knows that. And yeah, maybe you did, but like, it's not worth the effort, right, to fix that.
So you get to be a superhero on a network just because they're too lazy.
Yeah, pretty much. I mean, if you look at the cost benefit, right, like it's not worth their time and effort, right? Unless someone comes in and maliciously takes down all their network or uses all their metered data, it's not going to affect anyone.
Yeah, that's a good point, right? And then so it's just kind of status quo, like, well, or they don't know how to do it in the first place, right?
Yeah.
Wow.
Well, and you look at it like, well, I have X-ray vision, so maybe all of you want to start wearing lead clothing, and maybe some people do, but not everyone has X-ray vision, so is it really worth walking around with 100 pounds of clothes on?
Maybe you'll just see my nethers. Who knows?
Or maybe I'll just close my eyes all the time.
Yeah.
Wear lead glasses.
Right. Yeah. Actually, that's an interesting one.
Probably not the greatest analogy, but it came to me in a moment. So that's what you get.
So you had sent me some of. So you do talks all the time as well. Are you like? Do you have a bunch of those on YouTube as well, or are they mostly just slides?
I've been meaning to index them more thoroughly, but yeah, a lot of conferences will publish them and put the videos online. The most recent one that I know is online is from Troopers in Heidelberg in March, and before that there were a couple at Hardware I/O in September and Black Hat last year.
And what are you usually doing? So you usually like building a, or you're doing an exploit and then you kind of talk about it, or is it like you do more general stuff, or what?
Well, so I found that like I've started a lot more projects than I finish, which I know no one else has that problem.
No, definitely no one listening to this show.
It's unique to me.
Yeah, no one you're talking to right now.
So what I've kind of done is I've realized, okay, well, even the projects I've not turned into like a fully crafted, end product, I've learned something, and I can take a handful of these and put them together and actually get some valuable information out of them. So what I've been presenting on recently, and a derivative of this will be presenting at DEF CON this year, along with my co-presenter, Mike Leibowitz. We took a bunch of hardware security modules, right? So like YubiKeys, RSA tokens, and TPMs, and kind of looked at them and said, okay, well, what's the threat model that people used when they decided to use these devices? Like, okay, we think our computer's own, so we want a YubiKey that's going to be our login authority, right?
And that's like the thing where it like looks up the code over based on time or whatever, or network based or whatever.
Yeah, you touch it and it gives a one-time password that spits it out on your screen, into your like login box.
Okay.
And it's it's far more secure than just typing in a password that you remember that you keep in a passwords.txt file on your desktop.
Oh, okay.
But like, we trust these devices, and if we leave this device out of our sight for a few minutes, can we still trust it? It's a good question. And so we kind of went around and poked at different ways of cloning YubiKeys, which we didn't clone a YubiKey, but we made a fake YubiKey from scratch. And with this added feature that when you plug this YubiKey in, it not only shows up as a YubiKey, it also shows up as as a mouse. And so when you mouse over our webpage, right, the mouse jiggles, and that jiggling exfiltrates the key that's securing everything.
Whoa. Wait, what?
Did you follow?
No. So wait, you're saying that if I have this thing plugged in and I go to your website, it's going to do something?
So we took a YubiKey is a thing, right?
Yeah, sure.
We
Physical device.
made a device that looks like a YubiKey and acts like a YubiKey and authenticates like a YubiKey, right? But when you are not using your mouse, it jiggles the mouse around, right?
Huh.
So it shows up a mouse as well as a YubiKey, and it causes the mouse pointer to go up, down, left, right by 1 pixel, right?
Okay.
When you go to a malicious web page and you mouse over it, right, the JavaScript on the page is always grabbing the mouse coordinates, and it can decode the data that was being sent, right?
Oh my God.
Does that make sense?
Yeah. Because you're saying like there's like analytics plugins that do like where are people putting their mouse, where are all these things happening, right? That's always being captured, right?
Yeah.
Okay.
So basically we have this device that looks like a YubiKey, it's not a YubiKey. It smells like a YubiKey, it's not a YubiKey, but it also leaks out your secret key in the process. So
Wow.
just kind of undermining, changing the way people implicitly trust their hardware is what the objective is.
I mean, Joe, at this point, I don't trust a damn thing. I don't know if I don't even know if I'm talking to you anymore. Like, what is this even a microphone? Like, what? Wow. Okay.
Yeah.
Okay. So what is? So this is the one you sent me one of the talks. Is this like there's an RSA token as well? Is that the same thing, or is this a different talk that you're talking about?
Yeah, the RSA token. Mm-hmm. Yep. So the RSA token, we just kind of like said, oh, well, this device, it spits out a random, a cryptographic 6-digit number every minute. Like normally someone would try and get the key out of that, but instead, let's just add Bluetooth to the device and read the display and broadcast the 6-digit pin.
Yeah.
Okay.
Yeah, I guess that works too, huh?
There's all the matter of like how quick can you do it, how effective can you pull it off, and like does the hardware look like it's the original hardware when you're done? Who knows? But
right.
It's all worth a try. Exploring what's possible.
So what I'm hearing you say is that if we are going to design security devices like YubiKey or something similar, we should have like a squid. Or like one of those things when like bank robbers like rob a bank and then like they open up the bag and it spurts ink everywhere. You should have like something like that, like a tamper detective device or something and everything.
Well, I think the call to action that I usually throw at the end is if I'm getting a hardware device from someone, I should have a way of authenticating that it's legitimate, right?
Yeah.
And if you go to YubiKeys forums, you look on the back. It's you look at what they say. It's like, oh, well, does it say powered by Yubico on the back? Like, well, I can print that on the back of anything, and they do have a cryptographic way, so there is more to it than that. But like any device that you have that you want to trust or you're expected to trust, you should have a way to verify. The other side of it is one of the reasons we've gotten this situation is because hardware vendors don't understand or don't worry about security implications. So you buy an SoC from a vendor, you put it on a board, you sell the board to an OEM, the OEM puts a badge on it and sells it, and someone puts software on top and sells that. Nowhere along the way has anybody expressed any security expectations. So the SoC vendor might think like anybody who has physical access to this SoC can reprogram it. And that's a valid assumption. Sure. The problem is they don't pass that along. And, it's the first step in the process is making sure everybody passes along their security expectations. The silicon to the hardware to the products.
So what would that look like in a perfect world to you?
Well, I can't recall the router firmware, but basically, the vendor of silicon says, hey, we cannot guarantee anything if you have physical access to this device. And then they say that when they sell it to the board developer. And the board developer understands that, and they build a product, and they say to the software team, hey, by the way, we can't guarantee anything if someone has physical access to this device. And then the software team takes that into consideration and says, oh, that means that they can get access to anything that's on this device, and considers that when they design the software and market the product.
And so, I
sense?
think you're right. Yeah, I think so. Like they might put not that it couldn't be bypassed, but it might be like put a light sensor in there, so if the box is opened, it wipes the firmware or something like that.
Well, and then that's another path, right? How about hardware countermeasures, right? And at some point in time, people say, "Oh, we'll put a moisture sensor, so we know if you dropped your phone in the water. We're going to put a light sensor, so we know if you opened the case. And if you did that, then we'll void your warranty." But all the cases I've seen of that are mostly companies trying to protect their own IP and their own liability, not protecting users of the device and their data. They're also, in my opinion, expensive and often trivially exploitable as well.
I guess you go in a dark room,
open the
right?
case in the dark.
Yeah.
Yep.
That's
the old femto cells, the little grow cell phone towers.
Mm-hmm.
The original one, I think that AT&T had. When you opened up the case, there was wire, little plastic cables attached to a bunch of jumpers. And when those jumpers got pulled off, right, if you tried to power it on again, it would wipe some and set a tamper flag. And it was 3 or 4 jumpers that had a special arrangement. And if you put them on the wrong way, it would also set that tamper flag. So, there's all these tricks that some people have tried, but I don't know that there's many truly effective ones at this point.
Yeah. Right. Well, like you said at the top too, though. You said if someone wants to get in your device, they're going to eventually. So it's kind of more about, it's like a cat and mouse game of what's the most you can do for the reasonable cost. That's not, super. You have to be better than the competition, of course, and hopefully you're better than the majority of cases. But at a certain point, someone's going to get in. So, what's the most you can do?
How much can you expect to make by fully exploiting my system, right? What's the dollar value of the information on my computer, or, et cetera, et cetera. That's the indicator of how much effort it's worth to exploit you, right?
Yep. Yeah.
So if I have, top secret plans for next generation aircraft or something, that's a little different from having, a customer contact list and my email passwords.
Yeah. Well, but you're still saying, it's still important, right? It's still something that people should be thinking about. Uh-huh. So I guess where do you see the future of hardware security going? In general, with pen testing in general, of like device testing, everything that's out there, where is the general direction? Is it happening more? Is it happening less? Is there more needed? What's your opinion there?
What I see from the consumer electronics embedded device realm is in the past 5 years, suddenly vendors have stopped obviously marking JTAG and UART test points. They've started to, have dead consoles. They've started to disable JTAG on their devices. So there's progress even in the past 5 years. And so what can I see in 5 to 10 years? I see a situation where when I go to the store and I open up a device, right, it's going to be a PCB with 1, maybe 2 pieces of silicon on it, with no test points, no really understanding, because so much of the functionality is integrated into a single piece of silicon that anything except for silicon attacks are going to be very difficult. So from a hardware perspective, I think that's where it's going. I think that the golden era of hardware hacking on embedded devices is going to not last that long. Well, that's not true. It's gonna be a few more years, which is long enough.
Okay.
On top of that, we've also got software improvements, right? So as software gets better, as coding gets cleaner, we're going to have fewer and fewer software issues. And when software is harder to hack, anybody who really wants to get into a system is going to look for the cheapest spot, and that might be hardware, that might be silicon. So it's an ever-changing equilibrium. What people target is going to change over time, and we're going to slowly improve the hardware and probably slowly improve our attack capabilities as well.
And at the end of the day, it might end up being just go after the humans anyways, right?
Yeah, pretty much. Emails and stuff like that.
Yeah. Well, that's great. So where can people find you at, so you said your next conference is Recon, but where can people find you online and find out about where your next trainings are and everything?
So my website is securinghardware.com. I generally do my best to keep my latest trainings and keep links to all the presentations I've given and videos when they're available on there. And the upcoming group training is hardwaresecurity.training. And that's the joint training project between me, Joe Grand, Colin O'Flynn, and Dmitry Nedespasov. Oh, and I'm securely Fitz on Twitter.
That's great. Yeah, and definitely you've been sharing some great stuff on there. So thank you for being on the show today. I really appreciate it. Especially, I know this is last minute, so I appreciate your flexibility on that. And we'll hope to see you at conferences and talk to you soon.
No problem. Thanks for having me. Have a great day.